Next, let's review the dimensions of velocity, speed, acceleration, force, and see how derived units are found. Velocity. This is a quantity that is a rate and change of position. Speed is the magnitude of velocity and is the distance traveled divided by the time interval. So we can write the equation like this. Speed equals distance divided by time. To find the dimensions, we can apply the square bracket operator to every symbol. The dimensions of distance is length. The dimensions of time is time. And so therefore the dimensions of speed is length per time. We can then go ahead and rewrite the exponents as the dimensions of speed is length to the power of 1 times time to the power of -1. And there is no mass component, so it's mass to the power of 0. So then to find the SI basis units, we replace length with a meter, time with a second, and mass with a kilogram. So the SI basis units of speed are meters per second, or meters times second to the power of -1 times kilogram to the power of 0. Acceleration is the rate and change in velocity, and in the direction of travel is the change in speed divided by the time interval. We can write that in an equation like this. Acceleration equals change in speed divided by time, and then apply the square bracket operator. We know that the dimensions of speed are length per time, so then therefore the dimensions of acceleration will be the dimensions of speed with the time subtracted by 1 because we're dividing by time. So the dimensions of acceleration are length per time squared, or length to the power of 1 times time to the power of -2 times mass to the power of 0. Then, to find the SI basis units of acceleration, we replace length with meter, time with seconds, and mass with kilogram. So we get that the SI basis units of acceleration are meters per second squared. Force is the amount of strength needed to accelerate an object with mass, and its equation is force equals mass times acceleration. We can then apply the square bracket operator to this equation, and we get that the dimensions of force are the dimensions of mass multiplied by the dimensions of acceleration. So we can go to the dimensions of acceleration up above, and then increase the dimension mass component, increase it by 1. So we get that the dimensions of force is length to the power of 1 times time to the power of -2 times mass to the power of 1. And then to get the SI basis units, we replace length with meter, time with second, and mass with kilogram. And we get that the SI basis units of force are meter per second squared times kilogram. This combination of units occurs very frequently. We don't want to write it out all the time. So in honor of Sir Isaac Newton for his contribution to science, we call that collection of units the Newton, or capital N for short. So the derived unit of force is the Newton, and it's equal to a meter kilogram per second squared. As a matter of convenience, a derived unit is the name given to a specific combination of basis units that are multiplied and divided together. In total, there are 22 derived SI units, and a few of them are shown in the table below. The fourth column lists the basis units of the derived unit, and the last column shows how the derived unit can be expressed in other derived units. On the next slide, we will derive the joule and the watt.